The first one is a two-step. And again, you're going to ask yourself the same questions that we've been asking for the past 2 weeks. What's been done to y? The y, we have subtracted 7 and then we've divided by 9. You have to undo it in the opposite order, which means we have to take care of that 9 first. So if it's been divided by 9, the opposite of divide is multiply. We're going to multiply both sides by 9. That reduces down, and we're left with y minus 7 on this side. Now remember, this is where the center of our balance is. 9 times 5 is 45, and because there's different signs, it's negative 45. Now, once you did that step, is undoing the 9, now you have a 7 to undo. So what's been done to y? I've subtracted 7. The opposite of subtract is to add. So I'm going to add 7 to both sides. That cancels out. 7 0 pairs, leaves the y by itself on that side. We've isolated the variable. Now, these are different signs. That's a negative and that's a positive, which means that we're going to subtract. That's 38, and because the higher one is negative, it's negative 38. So what this student would have done would have punched negative 38 in the boxes, and that's how they would have recorded their gridded response. Any questions about number 1? Now again, this was not a multiple choice. They did not show you answer choices, so you could not go in and take A and plug it into y and see if it matched on both sides of the equal sign. You couldn't go in and plug B into y and C into y. They were expecting you to solve this on your own and come up with your own answer and be right. So this is what they're expecting you to be able to do as far as those two-step equations go that we've worked on this week. Now, this is the only one you can solve because it's the only one with an equal sign. All the other ones, all you can do is simplify it. Now, if it doesn't have an equal sign, the only way you can solve it is if this one would have said for n equals negative 8. If you knew what n was, then you could come in, plug in into the variable n, and then you could figure out, you could solve for this, but you can't because it's not an equation. We don't know what the other side equals, what it's worth, and they haven't told us what n is. So now the only thing we can do is just to simplify. So your directions for the ones that look like this is just going to say simplify the expression. So we know that this is a distributive set, a number in front of a parentheses set, and you're going to have to give everything that's on the outside to everything on the inside. So we're going to distribute this 1/2 to the 2n and to the 6. Now this is a fraction. We're fixing to multiply, which means we're going to multiply fractions. Are these fractions? No. What do we do to a whole number to make it a fraction? We're going to put a 1 under it. So now we can multiply across top and bottom. 1 times 2 is 2. 2 times 1 is 2. And these are n's. We're going to drop the addition sign. 1 times 6 is 6. 2 times 1 is 2. And now looking at what we have, 2 divided by 2 is 1. That's 1n. And again, they're not going to write the 1 in front of an n. If it's just 1n, you're just going to see the n. 6 divided by 2 is 3. And that's the answer. And that's the answer choice that you would choose. They're not going to leave it in this form. They're going to reduce improper fractions. And n plus 3 was the answer choice. Yes? It doesn't matter, but you're not going to see it in the answer choice as a 1. They're not going to ever put a 1 in front of the variable for you when it's just a 1n or a 1a or a 1x. It's just going to be that letter, that variable. Looking at this one, we did a couple of these this week just to show you that when you don't see that -1 out here, that is a 1 that has to be distributed. Now, in high school, you're going to be taught that if I had to distribute a negative into here, all that I'm doing is changing the signs to everything inside. When you see a negative or a subtraction on the outside of a distributive set and you don't see the 1, you're just going to know when you see a subtract and then there's this parenthesis set that all I have to do really is just make that a -2x and a -4. And you're going to see that in just a second because we know that this is keep, change, change. And that's really distributing a -1 into that set of parentheses. So this 3x just dropped. -1 times 2 is -2x. -1 times 4 is -4. And then drop the 5. So see, really all this was when I distributed that negative was just to change the signs of the numbers inside the parentheses set. And again, when you get into high school and you're doing full-blown algebra, Math 1, if you make it into Math 1 next year, that's just going to be the trick that they tell you. Just change the signs of everything in there. When it's just a subtraction on the outside because really you're just distributing that -1. Now that we've written all of this down, we've got two like terms. We've got a set of x's here, and we have a set of whole numbers here. So all we have to do here is combine those sets of like terms. We have a positive and a negative. When the signs are different, you subtract. 3 minus 2 is 1, so that's 1x. The higher was positive, so it's a positive x. We're going to drop the addition sign. Now we have a positive and a negative here. The signs are different, so we subtract. 5 minus 4 is 1. The higher was positive, so it's positive 1. So the answer here is x plus 1. And that was the answer choice that you would have chosen. Are you checking your work and correcting? Because that's why I'm doing this. I'm not doing it for me. I already know how to do it. Now, some of you are going to write that 1 here because you know that's 1x, especially when there's a negative in front of it and you know you're fixing to have to keep change. So you know to always go through and you're going to keep change, that's a -x, and you're going to keep change, that's a -12. I'm going to distribute this 2 first to everything on the inside of the parentheses. 2 times 3 is 6. I'm going to drop that addition sign. 2 times -1 is -2, and that's a set of x's. Then I'm going to come over here and I'm going to copy everything else so that I have my entire expression here now the way that I need it. When I do that, I'm going to see that I have a set of x's right here. And I have a set of whole numbers right here. So now all I have left to do is combine like terms. X is first. This is negative. This is positive. When the signs are different, you subtract. 4 minus 2 is 2 x's. The higher is positive, so it's positive 2 x's. Now I deal with my whole numbers. These are positive, these are negative. When they're different, you subtract. 12 minus 6 is 6. The higher is negative, so it's -6. Now, this is the same thing as 2x minus 6. Because if I keep change, that's adding a -6. Adding a -6. On this problem, this this is how the answer was in their answer choices. So even though you keep, change, change, and you do all this work, and you get down here and you see that this is the answer, if you don't know that you can keep, change, change, and go back to keep, change, change, and that those are the same thing, then you're going to not really know that the answer is there when it's the same answer. This is how they had the answer on that problem, even though this is how the answer looked when you worked it. So you do have to be conscientious that when you have changed something in here to work it, chances are when you get down here, you're going to have to change it back to find that answer in their answer choices. Now I say that, and I get down here and do this one, and it's totally opposite. We have to keep, change, change, but the one we come up with first is the answer choice in this one. And that's why I wanted you to know that, because sometimes when the answer is right in two different forms, you need to look at answer choices that are possibly two different forms. Any questions about number 4? Because this is the answer we got, but this is the form the answers were on the EOG last year. This is the answer choice that was there. Now, we're going to keep, change, change, so that's really a negative 3/8. Again, we did go back over our multiplying rules at the beginning of the school year and right before we started doing equations, because we went over our fraction rules and our integer rules in our notes just this week or late last week as we were starting to do these problems. So, I know I have to give this negative 1/2 to everything that's inside of the parentheses. I know fractions, I multiply across top and bottom. So, 1 times 1 is 1, 2 times 4 is 8. These are x's. One was a negative, one was a positive. When the signs are different, it is a negative. Drop the addition sign. 1 times 3 is 3. 2 times 8 is 16. These are the same, so it's positive. This is how the answer was on the EOG last year. They did not go in and do negative 1/8x, subtract negative 3/16. They did not change it back because we made a change in here. This was their answer choice this time. But again, you have to know that you can keep, change, change. If you don't see your answer choice, then do the keep, change, change and see if you see the answer choice then. Any questions about these 5? Because I pulled them straight off of last year's EOG for 7th grade. So, what we've been doing first quarter with fractions, with integers, and at the end and the beginning of this one with combining like terms, the distributive property, and solving 1 and 2 step equations, they expect you to be able to do that with proficiency. That's what they're checking you on. When I went and I looked at that EOG this morning and I pulled every single one that either had combining like terms, distributive property, or solving for a variable, or just simplifying an expression down, these were the only ones they had. Which meant if algebra is like 13% of your EOG, then you need to make sure that the ones that are on there regarding this, that you get them right. So I have on Google Classroom, because you saw with our science papers yesterday and the back of the math one, how the copier is copying and it's leaving parts blank and very light. I did not copy your sheet today because of that. So it is in Google Classroom. So you will be doing your work on your own paper, or you'll open up a doc and share that with me with your answers on it, but you still need to turn your work in so that I can see. Problems that we had this morning working these, because the majority of them are equations. There's an equal sign. You're going to have to solve on both sides. Was that students were trying to do this math in their head. There are too many steps in a two-step equation, especially when integers are involved. And you keep change, and you distribute, and you have to combine. And then sometimes it's okay, I have to do the opposite, so I have to do a multiplication or a division, and then the second step is I have to do an addition or a subtraction. And all of this stuff they're trying to do without putting anything on paper, and it is not going to work. It simply is not going to work. And I don't know how many problems we've done in the past couple of weeks where I have drawn that line down that equation underneath it and said, these are your two sides. What you do to one, you have to do to the other. And if you're trying to do that in your head, you're not going to get the right answer in these multi-step problems. So you do need your paper out. You do need to be copying that problem down first and then showing work for what you're doing. Any questions? These problems do take a long time. They don't take 4 minutes apiece, which is what I gave you this morning to do. So our goal today is to at least get 10, the first 10 on the sheet that I have shared with you, before we change classes. Any questions? Okay, you may go get a Chromebook.